Hi everyone, today we are going to talk about 5.4b, solving rational equations. In the last lesson, we learned about how to simplify, right, two rational expressions, but now we are going to solve rational equation. Equations, both sides are equal, and then solve for x, right? Equation, expression, you know the difference. So equation, you have an equal in between the both sides. Now, how do we solve the rational equations? Let's start with an example. First step, you have a same from last lesson. When you have a, rational expressions, you find the common denominator. So x plus 3, x plus 6. What is the common denominator? Both of them has a completely different. You just multiply, right? So x plus 3 times x plus 6 will be common denominator. And then what do? Yes, you convert both fractions using this common denominator. So you change this. X plus 3 times x plus 6, x plus 3 times x plus 6. The first one, you didn't have x plus 6. You multiply to this one, x plus 3. So you multiply same x plus 6 to the numerator also, so that you don't change the value, right? If you cancel numerator, denominator, it'll be just x over x plus 3. Make sense? Again, the second one, you multiply the x plus 3 here, then you should multiply x plus 3 to the numerator. And then, now here, you are not adding, subtracting yet, right? Numerator. You don't do it. Now, you found out common denominator. Then, here, you eliminate the common denominator. When you solve the rational equation, it makes much easier. So what do? Once you convert the both fractions by using common denominator, now eliminate, cross out both sides common denominators, just set numerators are equal to each other. All right. Once you convert both fractions by using common denominator, next is simply, then if the numerators are equal each other, the both sides are equal. Make sense, right? Numerators are equal because already denominators are equal. To be equal, the numerators must be equal to each other. Then both sides will be equal. You understand? So I will say x times x, you distribute the numerator. This is x squared plus 6x. And this is 8x plus 8 times 3 is 24. They must be equal. It's a quadratic equation. It's a linear equation. To solve it, what do? You should have everything in the one side, and the other side must be equal to 0. We learned it before, right? Then solve for x for quadratic equation. So what do? You move 8x plus 24 to the left side. That's better, right? Because x squared here is positive. If I have a negative x squared here, then I will move this one, the left side, to the right side. So that after you moving it, I want to have the highest degree become positive. All right? So x squared is the highest degree, so it's positive. Then you don't move this one. Instead, you move 8x plus 24 to the left. When you change the sign, you change the sign, right? So you are going to subtract 8x and minus 24. Change the sign. When you change the side, change the sign, right? Think about it. How do you move it? You buy inverse operation. 8x plus minus 8x minus 8x. Minus 24 minus 20. That way you did it, right? But that's same with changing the sign. All right. So 6x minus 8x is minus 2x, and then minus 24. Now we have quadratic equation, and you know how to solve this quadratic equation. What do? You factor them, right? You factor it. If you cannot factor, you should use quadratic formula, but this is factorable, then you factor and set each factor equal to 0 and solve it. So what do? You find the two numbers. When you multiply, it becomes negative 24. And when you add, it becomes negative 2. Can you find the two numbers? Yes, negative 6 and 4. So we will have x minus 6, x plus 4 equal to 0. Or you can use Kim's method, put the function in the calculator, you can find out zeros if you want, right? Then that's the abnormal method I told you. You find the answer first and then show the work later like that. So if you use the Kim's method in the table, you will know that in the table x equal to 6, x equal to negative 4. Then when you find the factor, opposite sign. That was. But now you know how to factor. Now what is next? X, you set this equal to 0, x plus 4 equal to 0, and so for x, then you get x equal to 6, and this one x equal to negative 4. And you are done. Do you understand? Good. So you want to now, when you solve for extraneous solution, you need to be careful just with one thing. We should know that when we get the solutions, we should know sometimes we need to plug it back and then check it. Because this is happening. Extraneous solution or root. Extraneous solution. What is it? When sometimes you plug the x value, numerator, denominator becomes 0, then it's not good, right? In the fraction, denominator cannot be 0. That's what we learned, right? If a denominator becomes 0, that is an error. If you put the calculator put in the calculator, let's put the 5 over 0 in the calculator. What do you get? 5 over 0 is not 0. It's error, undefined, right? 0 over 5 is 0. Likewise, denominator cannot be 0. So any x value which make a denominator 0, that's not good. So we call it extraneous solution. It seems to be right, but actually it turned out not to be right. Okay, so take a look at this. X squared minus 9 over x plus 3 equal to 0 when you solve it. Now, you already, so to make it 0, numerator must become 0, right? Then we are going to factor x squared minus 9, right? So it'll be x plus 3 times x minus 3 equal to 0. This is the same with x squared minus 9. So we should know numerator becomes 0, that will become 0, right? So when you solve it, x plus 3 equal to 0, x minus 3 equal to 0, right? So what is x? X is 3 or x is negative 3, right? That is the solution. But what did he say? X is 3, but x cannot be negative 3. Why? Why x cannot be negative 3? If you plug x equal to negative 3 into the denominator, what happened? It becomes 0. But we know that denominator cannot be 0. That's extraneous solution. So we should reject x equal to negative 3. So only solution is x equal to 3. All right? In this equation, only x equal to 3 is the solution. Negative 3 is not. That's an extraneous solution. we should reject it. All right. So you want to try one more time, one more problem. Now you have equations. Now, how do you find it? Is there any extraneous solution? You should try, right? So now, before you try, you know that denominators cannot be zero. That is possible candidates for extraneous solution. So here we know x cannot be zero. This one cannot be zero means x plus 3 cannot be zero, which is x cannot be negative 3. So x cannot be 0 or x cannot be negative 3. They are the extraneous solutions possible. So if when you after you solving this what is that rational equation, if you see any x value is 0 or negative 3, you should reject. If there is no x equal to 0 or negative 3, no problem then. Nothing to do. All right, so let's try. So common denominator, x times x plus 3. There is no common, right? X and x plus 3, there's no common. It's not x, all right? So x times x plus 3, x times x plus 3, x times x plus 3. You convert all the fractions by using common denominator. The first one, 2 times x plus 3. Make sense? Second one, you multiplied x here, then you multiply x, it becomes 3x squared. Third one here, same thing, you multiply x, right? The x squared. Now, we know that extraneous solution, x cannot be 0 or negative 3. Remember, or write down, it's up to you. You can write down x cannot be here, cannot be 0 or negative 3. But now, once you get the common denominator, what is next? Yeah, you set numerators equal to each other, right? But now be careful, you have a subtraction. So let's simplify. 2x plus 6 minus 3x squared equal to x squared. Denominators are equal, then numerators must be equal, then both sides are equal. Does it make sense to you? Now simplify, but you are in the different sides. What do you do? As I said, highest degree is x squared in the both sides. They are in the both sides. Then when you combine them, when you move together, which one should you move? This one to here or this one to here? I want to choose the latter. So this one. Why? Because when you move it, if you move the x squared to here, it becomes negative 4x squared. And then it's kind of, you can factor it, but it's harder. So I want to make it positive. So let's move everything here to the right side. Then change the sign, right? So it'll be 3x squared, x squared become 4x squared, 2x become minus 2x, 6 become minus 6. Everything is even number, then you can factor out by 2, right? Then 2x squared minus x minus 3. Now you should factor this one. You know Kim's method, right? You can do it if you factor it. So 2x minus 3, x plus 1. Where did the 2 go? Oh, you can keep the 2 here, or you divide the 2 both sides and then eliminate it already. You divide the 2 both sides. 0 divided by 2 is gone, right? So it's okay, right? So this and this is not equal, but I remove the 2. But if you want, you can keep the 2. It's okay. You can keep the 2. But this one, if you factor, I just assume that you know how to factor. So from here to now, 2x minus 3, x plus 1. If you FOIL it, you will get the 2x squared minus x minus 3. If you are not sure how to get this one, please go back to my previous lesson, how to factor quadratic equation. All right, you can find it quick. Then what do we do? Next, we set this equal to 0. 2x minus 3 equal to 0, x plus 1 equal to 0, and solve for x. You are done, right? X equal to 3 over 2 from here, x equal to negative 1 from this one. Are there any extraneous solutions? X cannot be 0, x cannot be negative 3. You should check it, all right? Look at the denominator. If you wrote down, it's easier, right? But now we don't see on the in these two solutions, there's no 0, negative 3. Then we finalize they are the solutions, proper solutions. So you don't need to reject anything. All right, that's it. So now you can just try to practice how to find a common denominator by yourself. This one, be careful. I will just give you the answer. All right, 6x plus 1, x plus 3. 6x squared is a common denominator. 6 and 2 common is 6. Don't make it 12, all right? Least common denominator. Think about that. X and x squared is x squared. You should think separately. Number part, variable part in this case. Now, this is a quadratic equation. This is linear. Then you should factor this one. This is x minus 4 times x plus 2. And the both of them has x plus 2. Then you just use 1 time. So x plus 2, x minus 4. So when you mostly the one denominator is a quadratic equation, right? Then when you factor it, the one factor will be this. That make it easier. Mostly, I'd say. If not, you should. If you don't have a common factor, then you should multiply all of them. It's harder. But mostly that's what I say, right? So this is x plus 2 times x minus 4, your common denominator like this. All right, so we'll stop here.